Okay, so we will derive this using simple math that we learned in high school, most probably. When I have this small triangle and this big triangle, we call them, these two triangles are resembling each other. Okay, and I don't need to go to the math about this, but if the triangles are resembling each other, then the ratio of the length of these triangles are the same. So if I look to the small triangle, which is this one, okay, so f of x, f1 of x minus f of x of 0 divided by x minus x of 0, okay, so this divided by this is equal to the total length of the bigger triangle divided by this, okay, so this will equal to f of x1 minus f of x of 0 divided by x1 minus x0. Okay, so in other words, this length divided by this length will equal to this length, bigger length, divided by this length. This is as simple as that. Okay. Now, what is the objective? The objective, I want to find the formula of f1 of x, and we will understand what is the meaning of this one. Okay. So it now becomes a simple mathematical equation. So this will becomes f1 of x minus f of x of 0 will equal to, I will multiply both sides by x minus x of 0. So this becomes equal to f of x of 1 minus f of x of 0 divided by x of 1 minus x of 0 times x minus x of 0. Then from this, f of 1 of x will equal to f of x of 0 plus f of x of 1 minus f of x of 0, okay, divided by x1 minus x of 0 times x minus x of 0. So the only variable here is x, this x and this x. The rest are constant. F of x of 0 is a number, f of x of 1 is a number, and so on and so forth. Now I will put this in this format. So f of 1 of x is nothing but, I will call this b0 plus b1 times x minus x of 0. So here I have two constants, b0 and b1, and multiply this with x minus x of 0. So I have the function in terms of x. And this, as we will show you later on, this exactly will be like the same as f of x equal to a0 plus a1 of x. This will be exactly the same function, and we will show you this in few slides. Let me see if there is any question here. Okay, so sorry. You are right. You are right. I made a mistake. Okay, so this is actually, it's not this. It's not this link. You are absolutely right. Actually, you are absolutely right. So it is actually this link and this link. This is the length of. So again, it is also valid, which is this length divided by this length is equal to this length divided by the other length. You're absolutely right. Okay, thanks for the correction. See if there's any other questions here. Okay. Okay, now we have written that. Now the difference between this formula and this formula, that this one I can get it directly in one step. Here, if you remember, we have to solve two equations to find a0 and a1. And here, no. and you will see that it is just one step. It's a little bit in a different format, but we'll show to you that these two formats are equivalent to each other. Okay, so now just to sum up what I did, this is for the linear interpolation. This is the one here refers to the degree of the polynomial. So this is the first degree. Okay, you will see later on 2, 3 means second degree, third degree, etc. Okay, so it is in that format where b0, this constant, is nothing but f of 1 at x of 0. Okay, and b1 is f of 1 of x minus f of x 0 divided by x1 of x0, which is the slope. This is somehow the slope of the line, somehow the slope of the line. Okay, so as I said, this is exactly the same, but unlike the direct method, we don't need to solve for some simultaneous equations. Okay, so that's for the linear approximation. Now let's see how we can deal with the higher order. So here we have a third order, and as I mentioned that, to a second order quadratic interpolation. For a quadratic, I need 3 points: so x of 0, x of 1, and x2, y2. Without the need to go through the approval, proof of how we got the equation, but the equation somehow it will be like a repetition of the previous one, and that's the beauty of the Newton method. It is once you understand the basics that we derived in the previous slides with the linear, as we go higher and the higher the order, you will follow exactly the same pattern. There is a pattern that we need to follow, and we'll see this pattern now. So f of 2, now we understand what does it mean. This is second degree, is equal to b0 times b1 times x of 0. These two terms are exactly the same terms we use them in the linear interpolation. Now I add to it, and you'll see here the pattern: b2 times x minus x of 0 times x minus x of 1. Okay, so I added this term to b2. Now the question is, what is b0, what is b1, and what is b2? Okay, so that's the format. Now if there is a third degree, you will see this becomes equal to plus b3 x minus x of 0 times x minus x of 1 times x minus x of 2. Okay, if there is a fourth degree, then plus b4 x minus x of 0 times x minus x of 1 times x minus x of 2, and finally x minus x of 3. So I can keep doing this. So this is the nice thing, that it has a repeated pattern. The only thing now is left how to find b0, b1, b2, b3, b4, and etc. Okay, now these constants, now I will show you the formula, but then we will derive an easier way to find all these constants. So b0, we know it. b0 is nothing but f of x of 0. We did that. And also b1, we did that. It is the slope between f of x of 1 and x of 0. So it's basically the function at x of 1 minus the function at x of 0 divided by x of 1 minus x of 0. Now let us see b2. b2 now it looks a bit different, but here it is the difference between the slopes. Here is the difference between the functions. Here is the difference between the slopes of x2 and x1. So here, if you notice here, this is f of x of 2 minus f of x of 1 over x of 2 minus x of 1. So it's a sort of the slope between x2 and x of 1. Okay, and minus, actually this is b1, minus b1 divided by the difference between x of 2 minus x of 0, the whole range that you are working with. what I'm trying to do here, without going into details and the mathematical proof, I'm trying to establish the pattern so that you can easily derive the equations. So this is for the quadratic equation. Let's see, B0 as I said. Now we will call B0 f of x of 0 in that format. B1, I will call it f of x of 1, comma x of 0, which is nothing but f of x of 0 minus f, f of x of 1 minus f of x of 0 divided by x of 1 minus x of 0. Now, B2 is the function of the three points, x0, x1, and x of 2, and it is f of x2 and 1, x2 and x of 1 minus f of x of 1 and 0 divided by x of 2 minus x of 0, and I will put it in that format. Okay, so this is nothing but this, and this is nothing but this. The square bracket, just to write it in a different format. There's no instead of having it as a normal bracket, that just to distinguish it. That's all. There is nothing else here. Okay. We are almost there. So if we have a cubic, how we will derive the formulas? Okay. So what we do now, if it's a cubic, if it's any order, so what we do? First, you write down the equations. X, the variable x of 0, x1, x2, x3, and these are numbers that we know. Then you will write in front of this f of x of 0, f of x of 1, f of x of 2, f of x of 3. Now, these functions also we can calculate because we know these numbers. And so I can find f of x of 0, f of x of 1, f of x of 2, and f of x of 3. Now, what I will do the following. This is the pattern that I was talking about. Okay. So this one now, f of x of 0 now, f of x, this is f of x 1, x of 0. This is f of x 2, x1, and this is f of x3, x2. Now I will come to what is the meaning of those. Now we'll do the same thing here. So this becomes f of x2, x1, x0, but this f of x3, x of 2, x of 1. And finally, I will have here f of x3, x2, x1, x0. So I think now you can see the pattern. Okay, now the question is how to find these numbers. Okay, now this is easy. We can find this directly. Okay, now how to find this? This is basically nothing but f of x of 1 minus f of x of 0 divided by x1 minus x of 0. See the pattern. This is why I write these two or draw these two lines. Okay, so I will write it down here. F of x of 1, x of 0 is nothing but f of x of 1 minus f of x of 0 divided by x1 minus x of 0. Okay, if this is the case, what is this? What is our f of x2, x1? With the same terminology, this will be equal to, again, this minus this divided by this minus this. So this becomes f of x of 2 minus f of x of 1 divided by x2 minus x of 1. So we finish all of those. So again, this becomes this minus this divided by this minus this. Now, how I can find this? F of x2, x1, x0. This is nothing but, again, this minus this minus this, which we already calculate now from the previous step. So this is f of x of 2, x, sorry, things get messed up. Coming back. Okay, so I want x2 minus x of 1 minus, so this, now I want, so this minus this, which is f of x1, x of 0, divided, now this is the question, divided by what? This is correspond to x2, so it's divided by x2 and this to x0 minus x0. So the whole interval. So this is cover x2, x1 up to x0. So we subtract or we divide by the whole range. Okay. Now let's see how I can find this. How I can find f of x3, x2, and x of 1. So this becomes this minus this, which is f of x3, x2 minus f of x2, x1 divided by the whole range, which is from x3 to x1. x3 minus x1, and so on and so forth. Now, if I want to find this nothing but this minus this divided by, we have here the range from x3 to x0. So divide by x3 minus x0. So with this, now I can have any order, and the format for this one now, let's see. Now, this is the function. 3 means third order. This is your B0. This is your, sorry, B0. This is your B1. This is your B2. This is your B3. So when you look carefully, this is your B0. This is your B1. This is your B2. And this is your B3. So I don't use any of the remaining items in B0, B1, B2, and B3 directly. However, I will need to do whole calculations to find the other B's, because, for example, B2 is nothing but this minus B1 divided by x2 minus x of 0. So I need to do the whole thing, but these, and you can look here carefully, this is f of x of 0, which is this one. B1 is f of x of 1, x of 0, which is this one. B2 is f x2, 1, and 0, which is this one. And finally, this is the last one. Okay, so let's have an example that demonstrate this clearly to us. And let's do it. Calculate everything here using the linear interpolation. This is, by the way, is exactly the same example we had it before. Okay, so this is the same example, but now instead of solving it using the previous approach, I will use a different approach, which is the Newton approach, and then I will compare my answer to the previous one and check, do we get exactly the same answer or a different answer? So this is the rocket. Okay, so here I have the t, my independent variable. Okay, and here is my velocity, which is my dependent variable. And what I want to find the velocity at t equal to 16. Okay, so I need to find the velocity somewhere here in between. At t equal to 16, I want to find v of 16. This is my unknown. Okay, we'll use the Newton divided difference method. This is what it's called. There is a division. We see that we divide, and there is a difference. There is a difference between the terms as we move on. We need to use linear interpolation, quadratic interpolation, and cubic interpolation. Now remember, in the direct method, when I use linear interpolation, then I have to what? I have to solve two equations. If I go for quadratic interpolation, then I have to solve 3 equations. And if you have to cubic, I have to solve 4 equations. Now, I will avoid all of this, and I will have direct solution to the problem as we will see. So let's start with the linear. Okay, that's a good question. And the question says that uh, in this method, we will still pick the closest points to the point we looked for. Yes, exactly. Thank you very much. For example, here, I want to find T16. For the linear, of course, it is 15 and 20. That's what I want to do. Okay, so let's move on. Okay, so first you have to write down the general format. This is the general format. V of t equal to b0 plus b1 t minus t0. Okay, so I will write down here the t, and I will write down here the v. So here we have t0 and t1. T0 is 15, T1 is 20. Why? Because 16 is somewhere between. And then the velocity, I will get the velocity from the table, which is this and this. Okay, so we will have this as 362.78, and this is equal to 517.35. Okay, so this is what I call it V at t of 0. This is V at t of 1. So this is are given in the data point. I already know them. So here it's first order. So the only thing I have to do is to find this value, okay? Which is, now this is, as I mentioned before to you, this is your B0. What is left is B1. What is B1? B1 is nothing but this minus this divided by this minus this. So it becomes 517.35 minus 362.78 divided by 20 minus 15. Okay, and this is equal to 30.914. Okay, so my V of t is equal to B of 0, which is this one, 362.78, plus my B1, which is this one, which is 30.914 times t minus, what is t0? T0 is this, minus 15. So this is my equation. Now, if I open this terms, so this plus 30 times minus 15, I will get minus 100.93 plus 30.914 t, and this is valid from t less than or equal to 20 and 15, and this is exactly the same formula we had it when we used the direct method. This is exactly the same. So yes, the format is a little bit different, but we got exactly the same formula. Okay. Now let's move to the. Okay, let's see the questions before we go to the second part of the question. Oh, so if we use Newton's method, you want us to simplify it down? No need, no need, because I just want to show it to you that these two equations are the same, but you don't need to simplify it to that format. Okay, this is absolutely correct, and this is actually the format in Newton's method. So you don't need to further simplify it. You just keep it as it is. Okay. Okay. So let's move on. And here we calculate the V of 16 using this formula. So we get the same answer we got before. Okay. Now we want to use the quadratic. So now the quadratic, we will use 10, 15, and 20. Okay. And remember, we want to find t equal to 16. So we selected, remember last time, there is another one point which is 22.5. However, we selected the 10 because the 10 is closer to the 16. Okay. So let me do here. So this is, we have 10, 15, and 20. And then we have VT of 0, which is 227.04. 362.78 and 517.3035. Okay, so I want now to use the second order polynomial. But before that, let's remind ourselves how the formula will look like. So your v of t will equal to b of 0 plus b1 t minus t of 0 plus b2 times t minus t1 multiplied by t minus t0. So this is the format of that. Now, this is your t0 and this is your t1. So I already know this, I know this, I know this. So what is left is b0, b1, and b2. And this is from the configuration here. I will find it. So I will do this, okay? So now this value, which is, so we know that this value basically is what? This is your b0. Now I will find b1, which is basically nothing but 362.78 minus 227.04 divided by 15 minus 10. And this number is nothing but 517.35 minus 362.78 divided by 20 minus 15. Okay, so it's as simple as that. Now this is equal to 27.148, and this one is equal to 30.914. Okay, now there's no space here, so I will continue here. So I will have here the 10, the 15, the 20. We got our 27.14 and my 30.914. Then, so this is my B1. Now my B0 will be, or sorry, B2 will be this minus this, which is 30.914 minus 27.14 divided by the whole range now, which is 20 minus 10, and this gives me 0.37660. Okay, so now my V of t will be what? My V of t will become B0, which is this number, 227.04, plus my B1. What is my B1? It is this number, which is 27.148 times t minus t0. What is t0? Is 10. Plus my B2. What is my B2? My B2 I just calculated, which is this number, 0.3766 times t minus t1, which is 15, times t minus t0, which is 10. Okay, that's it. So this is my V of t. Now, if I want to find my V at 16, just substitute every t here, every variable t to 16. And if you do that, you will find this is 392.19, which is exactly the same number. So this formula actually is exactly the same formula we will get. But here, look how convenient is this one, and even how easier to be programmed. This is the Newton method, although actually we will not have any simulation assignment for the interpolation. The simulation assignment is only for regression. It's very hard to include everything in the simulation assignment, so I have to pick certain topics, but this will be definitely in the quiz. So as you can see here, there is no need to solve anything. It's very very straightforward. So here is the solution. Now, this is the substitution, and then we found the error, and as you can see here, the error, and it's less than 0.5%. So the answer is good for 2 significant digits. That's exactly what we got in the previous one. Now, let's go for the last part of the question. When we have a cubic, now this looks a bit messy, okay, but actually it's not. It's now becomes very straightforward. I'd like to do it again in details so that you guys. So this is, I mean, this is the longest thing I can give to you. Okay, so I will have here the T0, which is 10, 15, 20, and remember 22.5. We picked the closest point. Okay, now we will have in front of this f of t of 0. This is from the data. So far, the t's and the voltages the velocities identified at these points are all from the data. So we'll have here 227.04, 362.78, 517.35, and finally 602.97. Okay, very good. Now I want to start solving this problem. So what I will draw this and this and this. Okay. Now I know for a fact that this is now the first constant, which is my B0. Okay. Now I want to find B1. So B1 is nothing but this minus this. So this is 362.78 minus 227.04 divided by 15 minus 10. And this give me the 27.148, the one that I just calculated. Then I will do this one, which is, again, we did that in the previous example, 517.35 minus 362.78 divided by 20 minus 15, which is giving me 30.914. Finally, this one, the last one, which is 602.97 minus 517.35 divided by this minus this, which is 22.5 minus 20, and this will give me 34.248. Okay, now I found B1, which is this. Now I will continue. Okay, so this now becomes 30.914 minus 27.148 divided by, I mean, this is the only thing that you have to pay attention, 20 minus 10. Why? Because this is covered this whole range, which is 20 minus 10, and this will give me 0.3766. This is exactly what I got from the previous step. And finally this, which is 34.248 minus this, which is 30.914 divided by y, 22.5 minus 15, which is this one. So this is the whole range. This goes from here to here, and this will give me 0.4445. Okay, so now I found B2, which is this. Now I will take these last two numbers, I will take them here, which is 0.3766, 0.4445, okay, and I will have it as such, which is 0.4445 minus 0.3766 divided by, from the beginning to the end, 22.5, 22.5 minus 10, and this will give me 5.4347 times 10 to minus 3, and this is my last constant, which is my B3. Now everything is settled. I have all the constants here. So now here is my V of t. Now this is my t of 0, which is 10. This is 10, and this is 15, 10, and this is 15, and this is 20. So we have everything. Now in one shot, I will have this. This is my equation now. Or here it is with everything I calculated. It's there. Okay. Now I can substitute V of 16, and I get exactly the same answer, exactly the same error, which is less than 0.05%. And we said that there is 3 significant digits now in this last answer. And here is the summary of the results, which is the same like